Hello, I'm Sudam and I'm start with the introduction and background part. The importance of IoT and current limitations. It starts with rise of the IoT. Today, IoT is everywhere in our homes or cars or cities. These devices collect a huge amount of data every second, but many of them have a very limited storage, low processing power, and small batteries. When all this data is sent directly to the cloud, the system becomes slow, the network gets crowded, and privacy concerns appear. So the traditional cloud model can't always provide speed or reliability we need. And the transition from cloud to edge computing and sending everything to a faraway cloud used to be normal, but now many modern applications need real-time responses. Waiting for data to travel to the cloud to back simply takes too long. Edge computing solves this by moving processing closer to the device. It handles the data locally, reduces delay, and makes the whole system faster and more efficient. And the benefits of edge computing architecture. Edge computing reduces the time between devices and the server, which means much faster responses. It also saves energy because of data doesn't need to travel long distance. Different communication models like machine to machine or machine to cloud or machine to gateway create a lot of data, but edge computing helps keep latency low. Overall, it makes IoT system quicker, lighter, and more energy friendly. And let's start with background part. The roots of the edge computing go back to 1990s with content delivery networks. Content delivery networks brought content closer to the users and reduced load and central servers. They improved availability, performance, and security. This distributed approach became the first strong step toward the edge architectures we use today. And transition to fog computing. In early 2000s, mobile devices and IoT grew very fast and cloud systems started to struggle. In 2012, Cisco introduced the idea of fog computing. It aimed to push computing power closer to user. It wasn't a full model and lacked standards, but it shaped the directions of modern age computing by highlighting the need for distributed process. And the final part is the fifth generation era and standardization. A key moment came in the 2015 when companies like Cisco, Intel, Microsoft, and Dell formed the OpenFOG consortium to create official standards. Later in the 2020s, 5G technology changed everything by making communication extremely fast and reliable. With these improvements, edge computing become essential for real-time, secure, and high-performance iOS systems.
Hello, sir. My name is Mustafa Emirhan Yılmaz. I'm gonna present literature review part. IoT data growth and restriction of edge computing. We start with the main problem of today. In recent years, exponential increasing IoT device numbers cause huge size of produced data. Although traditional cloud computing architecture provides strong solution, transporting data to central server creates an unacceptable latency and high bandwidth problem. Also, it brings physical security risk while data going back and forth, especially for autonomous vehicle. Energy efficient processor and AI accelerators. In this section, we look at the hardware solutions. The focus of academic research has slipped from maximum frequency to energy efficient because most devices work with battery. Most common solution is heterogeneous multi-core architecture. For example, study on big data Lidl architecture shows that if high-performance tasks work with big cores and background tasks work with little cores, total energy consumption reduced 40%. memory hierarchies, PIM, and hardware security. We talk about memory and security. Memory wall was on, Memory wall was one of the most problem became a bottleneck. Analysis indicate that data transfer from DRAM to processor was needed energy consumption more than 100 times rather than computing. PIM architecture was recommended for this problem. Also, permanent memory technology like ReRAM provided that protect data and possible instant opening. In summary, literature indicates a paradigm shift. Processor speed is not a success criteria now. Energy efficient and secure design coming to forward. This is the golden era of computer architecture. Thank you for listening.
Hello, I'm Muhammed Emir Demir and I'm gonna talk about potential vulnerabilities in edge computing in this section. First, I will talk about security and privacy issues in edge computing. Edge devices are placed so close to users and often in public areas, so they are easier to access than cloud data centers. And as you can see here, one major risk is malicious hardware or software injections. Attackers attackers can physically reach devices and add unauthorized components to steal data, to avoid authentication or send false data, maybe. Another risk is side channel attacks. Information like power usage or communication signals may look harmless, but attackers can analyze it and they can use it to extract sensitive or like personal data. Finally, weak physical protection, weak passwords, and missing multi-factor authentication increase the data and authentication risks. And next slide, we have hardware and energy limitations. Edge devices are small and energy efficient, which means they have limited hardware resources. They usually use low power microcontrollers with limited memory and processing power, so it makes it more difficult to run some complex tasks on those devices. And also, most devices run on batteries, so energy must be saved. But there's a problem here because wireless communication uses a lot of power. So we can only use wireless communication to send necessary and important data that we had to send. We, and also compressive sensing at last. This helps by reducing data during collection, which saves energy and computing power. And finally, we have reliability. Reliability is a major challenge in edge computing as well. When a server fails, it is often hard to find the exact cause. It can be battery loss, weak signal, or maybe sensor failure. So our system must constantly monitor all components to stay reliable. And bad conditions like low battery or unstable network can cause unreliable data and breaks reliability of our system. And unfortunately, full reliability at the edge computing is still difficult to achieve even today. Thank you for listening to me and my friend gonna talk about recommendation for improvements.
Hello, I'm Sude. In this part of the work, I will talk about security and privacy solutions that work in edge computing based IoT systems. My goal is to explain the main protection methods in a simple way. First, I will explain package filtering. Package filtering controls which packets can enter the network. Some packages are allowed and some are blocked. This helps stop unauthorized access. Second, I will talk about firewalls. Firewalls can be software or hardware. They check the traffic and block dangerous data. There are different types like stateless, stateful, and proxy firewalls. Stop malicious software ways. Some methods can check device signals, some compare normal and infected circuits, and other replace or change parts or remove threads. Intrusion detection systems or IDS watch the network and report suspicious activities. There are many models designed for edge computing, including layered IDS system and real-time monitoring systems that can detect injection attacks. Cryptography. Normal encryption uses too much power for small IoT devices. Because of this, lightweight cryptography is becoming popular. These algorithms gives good security with less energy. Another important logic is authentication. Devices and users need to prove their identity, even when they come from different trust domains. This keeps communication safe. I will also include in auditing, which means recording, logging attempts, and access change. This helps find security problems. Before using the system, security testing is done. It sends the signals and simulates attacks to find weaknesses early. Finally, I will explain secure data aggregation. Devices encrypt their data and send it to the edge node. The edge node combines the data without seeing the real content. This protects privacy and reduces duplicate data. To finish, I will mention best practices, strong access control, monitoring changes, using IDS at the edge, and treating the edge as a special environment that needs its own rules.
Now I will briefly conclude our presentation by summarizing the main points of our study. For overall conclusions, edge computing has become a key architectural shift due to the rapid growth of IoT devices. By processing data closer to the source, it reduces latency, bandwidth usage, and reliance on cloud systems. The evolution from CDNs to fog and 5G enabled edge shows that proximity-based computing is now essential for real-time IoT applications. And based on this, I will now summarize the key technical findings. Our findings show a shift from general-purpose processors to energy-efficient, specialized hardware. Technologies such as SoC designs, hardware accelerators, and processing in memory improve performance under energy constraints. However, battery life, thermal limits, and memory issues remain major challenges, and hardware-level security is therefore necessary. And finally, I will briefly discuss the feature outlook and edge computing. Despite its benefits, edge computing faces challenges related to security, reliability, and limited resources. A sustainable edge ecosystem requires energy-efficient hardware, adaptive security solutions, and continuous monitoring. In conclusion, edge computing will remain a core technology for scalable and intelligent IoT systems. And thank you for your attention.